All right, so this is more practice, but this time we are going to be turning this perspective drawing into a Fisher projection. This is at 2625 in the 4.7, 4.11 video. Okay, here's what we're going to do here. So this is a perspective drawing, and we're turning this into a Fisher projection, which is just across like this. And whenever we think of Fisher projections, see, that's going to be a little confusing, right? We think of this. Okay. When we think of a transfer between the two, well, specifically when we think of going in this direction, we think left, ledge, wedge, and right, light, meaning light lines dashed, okay? So we will remember this. Okay, let's assign stereochemistry. Let's figure out if this perspective drawing is in the R or the S. R meaning going to the right, clockwise. S meaning going the other way, okay? All right, so bromine, we know, has a high atomic number, so we're automatically just going to give that the first priority. Hydrogen has the lowest priority here, number 4. Now, we already see a problem because hydrogen is not coming out of the page. It's going, or it is coming out of the page. It's not a dashed line. We like dashed lines, and we need hydrogen to be that dashed line because it's the lowest ranked. Let's finish out our other rankings here. This carbon here is attached to hydrogen twice, or 2 hydrogens, and 1 oxygen. So its stereo ranking, which I'm calling this, is this. This carbon is attached to 3 hydrogens. When we compare the two, oxygen beats out hydrogen easily. So this is going to be the second priority. And this one is going to be our third priority. When we draw our line from 1 to 3, not like that. We draw our line from 1 to 3, we're going to the right. This is in its R formation. But, look at our hydrogen. We need to swap positions 1 and 3. We need to make a swap. Because we need to make a swap, although this is going in the right direction, this is going to be in the S. This is an S isomer. Okay? Even though it's going here. Okay. That's fine. I don't know that we make that change as we transfer. But I'm going to work backwards here and say, if we got this perspective drawing, what does the Fisher projection look like? Okay. Well, we know right is light, so what's going to go on the right? Well, the CH3. And we know left, ledge, wedge, so the hydrogen's going to go here. The CH2OH, now I think technically, because this is the most oxidized carbon, or something like that, it goes up at the top, and that's why it's kind of already at the top here. And I think that means because it's close, very close to the electronegative oxygen, loss of electron oxidation. Oxygen is pulling electrons, which means that's why this is going up top. And we're going to put the only thing that's left, which is bromine, down here. Okay? So right is light, CH3, left, ledge, wedge, which is going to put this wedge on the left. And this was already drawn this way, but remember, like an antenna, this dotted line is going to go above the wedge. Okay, so cool. All right, anyway. Okay, so now what do? We carry our rankings over. Bromine was 1. Hydrogen was 4. CH2OH was 2. And the CH3 was 3. Double check those. I think that's pretty solid. 1. So what direction is our arrow going? Well, it's also going to the right, which would initially make this an R. However, look at our hydrogen and look at our rules for Fisher projections. For a Fisher projection, your vertical line is king. Your vertical line is what's going into the page. We want our hydrogen to be going into the page. But, well, his rule for this was you needed to swap the 3 and the 4. They're not next to each other. A swap of doing that isn't actually going to help me here. So now we really have a problem. If we did make this swap, that wouldn't do anything either. This would just put the CH3 on the left and the H on the right. So I'm not sure. Let's see what he says for this.
This into a Fisher projection formula. What do? I'm going to first draw this CH2OH here and bromine at the bottom. The one on the solid wedge goes to the left, and the one on the dashed wedge goes on to the right.
So far,
this is the correct representation.
Maybe I screwed my rankings up.
Know? Let's find out the stereochemistry, find out what the designation is for the chiral center. This is the chiral center. I'm going to assign this as 1, 2, 3, and 4, right? Hydrogen is not into the plane of paper, so we will have to swap. But in any case, you can simply say 1, 2, 3 is going this way. It's clockwise. Hydrogen is coming towards you, so it should be S configuration.
Woo!
Right?
Woohoo!
What about this configuration? I have 1 here, 2 here, and 3 here. And the hydrogen is coming towards you. 1, 2, 3. Right? It is clockwise, but hydrogen is coming towards you. Clockwise is R. You're going to swap it to make it S. All right? But the question is also asked.
Okay, so so he is contradicting what he's saying. He said you would swap a 3 and a 4. I guess that's not the case for a Fisher projection. It doesn't matter if you do a swap or what. I think that was maybe just a conceptual thing. We knew something was wrong because as we're going from 1 to 3, which would be in our configuration, but hydrogen is not where we need it to be, so this would also be an S. He's asking for a mirror image of, I think, the Fisher projection, which we just drew. So the mirror image of that would just be, if you were putting that up to a mirror, well, would just be this.
Can you write down the enantiomer of the Fisher projection formula?
And if we're doing an enantiomer here, and this is 4, this is 1, this is 3, and this is 2. Well, let's look at what happens here. If we're going from 1 to 3 this time, we're going this way. To the left, which normally would be an S. However, our hydrogen still isn't where we want it to be, so this technically would be an R.
And you can do that too by simply doing this. And I may not ask you all the little steps. I may ask you, I'm going to give you this perspective formula, and the question will say, which of the following is going to be the enantiomer of this starting material? So starting is A. You're going to pick the compound B here on the right as the enantiomer of the perspective formula A. So you have to do all this in your mind or on the piece of paper or on the board. Preferably, I'm actually looking forward to seeing all the boards because you will need a board. Again, the exam is next week. Order today if you do not have a board. So you're going to do this on the board, on your scrap board. Maybe have a duster around or a piece of paper that can erase the duster, erase the board so that you can go on moving on to the next question. Anyway, you're going to learn how to do the perspective formula into the Fisher projection and then pick the right enantiomer. So this is the right enantiomer. And then you can actually confirm, well, this is the number 1, number 2, number 3, number 4. And if you do this, the configuration here would be S, but since hydrogen is coming towards you, you are going to swap it to R. So the correct configuration of this molecule in the Fisher projection formula is R, and the original was S, and now you know that you converted this perspective formula into its enantiomer correctly. I hope you're with me on this. If you have compounds